Hi dear students, in this video we are going to study about multiplication of a vector by scalar, and we are going to study about standard base vectors. Here the definition of the multiplication by scalar, as you see here, v is a vector, v1 and v2, they are the components, c is an element of real numbers, then c times v means you are going to multiply each component by this c, and you are going to get the new vector, which is c times v. Here, to understand this one better, we are going to solve directly the question like minus 2u and 3v, then 3u plus 2v. Let's find them. These are one by one. Let's start with minus 2u firstly. Minus 2u is equal to minus 2 times the scalar. I'm going to write directly inside, or let me write directly inside. Minus 2 times u is equal to minus 3, 2, so it's going to be like times minus 3 and comma minus 2 times 2, it's going to be, which is equal to here 6, and minus 2 times minus 3 is equal to 6, and minus 2 times 2, it's going to be equal to minus 4. So this refers minus 2u, and I'm going to write 3v now. 3v vector, it's equal to 3 times the v vector is equal to 2, 3 times, and the comma 3 times again, 3 times minus 1 it has to be, which is going to be equal to 3 times 2 is going to be equal to 6, and 3 times minus 1, it's going to be equal to minus 3. And the last one, 3u plus 2v, it's going to be, it is not a difficult operation. 3u plus 2v is equal to 3 times u elements are minus 3, and 3 times 2 here, plus 2 times the v, it's equal to 2, and 2 times minus 1 it has to be. Okay, with respect to this one, 3 times minus 3 it's equal to minus 9, minus 9, 3 times 2 is equal to 6, and plus 2 times 2 it's equal to 4, and 2 times minus 1 it's going to be equal to minus 2. So this is going to be equal to, when you add them, minus 9 plus 4, minus 9 plus 4, I can skip this, but I wanted to show for the first time, and 6 minus 2, 6 plus minus 2, which is equal to 6 minus 2, and then the answer is going to be equal to minus 5, and 4 it has to be. Okay, we are going to deal about the properties of the multiplication. I'm going to simply explain what these are, and I'm not going to write lots of things here. Firstly, you can multiply, you can distribute the c over addition. And this scalar can be distributed over addition. This is distribution property, a kind of distribution property, we can say. And if you are adding c, like you are distributing the vector over the c and d scalar terms here, it might also, you can distribute the vector over the addition, also it can be. Here you are associating the scalar terms, that doesn't change the result. 1 times 1 is the identity, 1 times u is equal to u, 0 times u, 0 is the additive identity, but it's it makes the, when you multiply by 0, it makes the thing 0, so 0 times something is 0, 0 times 0, c times 0 vector, it's going to be 0 again, and this is the last part, the distance of the u you multiply by c, it is not different than absolute value of c. Here the sign used as an absolute value, and this shows the distance also. We need to mention that one, that's the difference here. Okay, let's continue with the standard base vectors. What is standard base vectors? A vector of a length 1 unit is called unit vector. Here, if we give as an example like W is 3 over 5 and 4 over 5. This is called unit vector because the distance of W, it should be equal to, if you remember from the formulas, U is equal to U1 and U2, and not plus, where U1 and U2, then the distance of U vector was equal to U1 square in square root plus U2 square it was. So here for this one, the result, it's going to be like 3 over 4 square plus 4 over 5 square it should be, and then it's going to be equal to square root of 9 over 16, pardon, 9 over, I have written here wrong, 9 over 3 over 5 it should be. So this changes this value here, which is 9 over 25 plus 16 over 25, which is equal to root 25 over 25. That's equal to 1, root 1, and this is equal to 1. So we can call W as unit vector. For any non-zero vector here, U, this is non-zero and it is not unit vector. Here, U vector divided by the distance of the U, then it is called unit vector. It might be unit vector by dividing this one. Here, we use this one to find the directions of U. There are two important unit vectors also here. One of them is I and J. We are going to use these terms. I defined as 1, 0, J defined as 0, 1. And we can write all the vectors in terms of I and J. And we call these vectors our standard base vectors at the same time. We are calling them as standard base vector. And here we are going to solve some question with examples. Okay, here the vector U is equal to 5 and minus 8, and we are going to write these are in standard base form, and U is equal to 5 and 8 minus 8 is equal to, at the same time, we can write 5i plus minus 8j. Also minus 8j. So it's going to be equal to 5i minus 8j also it might be. Okay, the second one here, here we have u vector, v vector, and we have here linear form of 2u plus 3v, which is also, I can write here like this, 2 times u plus 3 times v can be written like 3i vector plus 2j vector times 2 and plus 3 times here minus i vector plus 6j vector also it might be. Here I think we can use the distribution law as you know that one. I think you know that one. We can use the distribution law. Here 2 times 3i, which is equal to 6i vector here, plus 2 times 2, it's equal to 4j vector here. And we are going to multiply, and we are going to use the sign also. 3 plus 3 times minus I, it's equal to minus 3i vector, and plus times plus, it's equal to 16. 3 times here it's going to be 6, which is equal to 18j vector. And here, when we add this one, 6i vector minus 3i vector, it's going to be equal to 3i vector. And 4j vector plus 18j vector, it's going to be equal to 22j vector. It has to be. Okay, this is the last part of our video, and here we are going to try to find the components of the vector by using trigonometric substitutions. Here, if we say there are two components here, one of them is the horizontal component is the v, for the v vector we are talking. This is vx and this is vy it's going to be. So if you want to find v, also you can write v1 times I plus v2 times y here. We can write. So if you want to find the components, also you can use the trigonometric substitutions. If you remember from the trigonometry, I'm going to use here, I'm going to try to draw one right triangle. And in this right triangle, let's say here, this one. In this right triangle, if you choose this angle as theta, the sides are A, B, and C. It's obvious that this is 90 degrees here. And the first trigonometric ratio is sine theta that we are learning. It's equal to B over C. It's going to be opposite over hypotenuse, which is here, if you want to derive and if you want to find the B value, which is opposite side, okay, B becomes equals to C goes to other side, C times sine theta it has to be. So when you derive the formula, you are getting this expression. And it's same here, B becomes the Vy and equals to C, which is the here, which is the length of V also, and then sine theta, the angle is sine theta. What about this is for Vy, we are talking about the opposite value, which is on the y-axis. What about the adjacent side? It is which is on the x-axis. It is Vx, and the length of V times cosine theta it has to be. Okay, now we are going to solve this question. The length of V is equal to 4 centimeters, and the angle between V and the positive axis is equal to 60. Then find the horizontal and vertical components of V. Express V in terms of I and J. Firstly, let's write the here. Let me draw one trigonometric. I'm going to draw coordinate plane here. One simple coordinate plane here, let's say. And then on this coordinate plane, let me change the color here. I'm going to draw one V vector. It is standard vector, I mean position vector, which starts from, and the angle which starts from origin, and the angle is 60 degrees, and the length of the vector V, the length is equal to 4 units. So how to find the Ux and Uy? Firstly, we are going to concentrate to that one. So Ux is equal to length of U. I'm sorry, always I'm confusing this Ux and Vx. Okay, Vx is equal to length of V times cosine theta, which is equal to 60 here, and Vy is equal to again length of V times sine theta. It has to be. Then we are going to write the length of V is equal to 4, and cosine 60 it should be equal to 1 over 2. From the trigonometric values we remember this one. So this is Vx, and Vy it should be equal to the length of V is equal to 4. It's not going to change, and sine 60 it's going to be equal to root 3 over 2, which is equal to here 4 over 2, and that's equal to 2. Vx is equal to, if Vx is equal to 2. Vy it should be equal to, I'm going to continue here, 4 root 3 over 2, which is equal to 2 root 3. And 2 root 3, it's going to be, if you want to mention this one in terms of, normally v is equal to 2 and 2 root 3. But if you want to mention this one as ij, it's going to be equal to 2I vector plus 2 root 3j. Okay, this is the end of the video.